A rectangular vessel, when full of water, takes 10 minutes to be emptied through an orifice in its bottom. How much time will it take to be emptied when it is half filled with the water? That means this is your container and there is a small hole here right now. It has been filled with the water. There is a small hole here right now. From this hole, the water has been coming out. A rectangular vessel, when filled with water, takes 10 minutes to be emptied. And if the height is, say, for example, capital H. Okay. So in order to move from capital H, and empty means capital H is becoming 0. Time taken is how much for me? T1 is equals to 10 minutes it is taking. It is taking how much for me? 10 minutes. Okay. How much time will it be taken to empty it when half filled with the water? Now the same vessel when it is half filled. This one is half filled. This one is H by 2. And there is an orifice here. So now from height H by 2, it is becoming for me 0. For this one, what is the time taken is asking. This is the question. Can anyone try it? Time taken to empty the vessel. I hope you remember the formula. T is equals to your capital A by your small a under root of your 2 into your H divided by G for emptying the tank. This is the direct shortcut formula. For emptying the tank, T is equals to capital. Capital A is the area of the vessel. Small a is the area of your orifice. Capital A is your area of vessel. Small a is your area of orifice. Okay. H is the height, original height. G is acceleration due to gravity. So capital A is a constant. Small a is your constant, 7 minutes. Okay. Let's see. T is directly proportional to your root of your H. So I can write here T1 divided by your T2 is equals to under root of your H1 divided by under root of your H2. Okay. So T1 is given how much in the problem? 10 minutes divided by T2 we need. That is equals to. It is emptying the tank right now. So emptying the tank right now, initial height is nothing but equal to your H. Final height is right now under root of your H divided by 2. That means this will become for me root H divided by root H into your, this root 2 will go up. So this one is root 2. Root H will get cancelled. So T2 will be equal to your 10 by your root 2. So that will be equal to approximately 10 divided by root 2 value is 1.4. Done, beta? So T2 is equals to 10 by 1.4. How much it will be, beta? 100 divided by 14. 10 by root 2. Approximately. How much, beta? How much? Aisha Fatima, Munas. 100 by 14. Approximately 7 minutes. Okay. $7.14. Yeah. 7 minutes approximately I can take it out as per the options. So options given are 9 minutes, 7 minutes, 5 minutes, 3 minutes. So answer will be equal to 7 minutes. Next question. A metal plate of area. So here got an area. Area is equals to 10 centimeter cube. Sorry, square. Rest on a layer of oil 6 mm. Thickness is given for thickness is given as of here 6 mm. A tangential force is equals to 10 power minus 3 Newton is applied on it to move it with a constant velocity. Velocity is given as 6 centimeter per second. Coefficient of viscosity of liquid is how much? Neta value is equals to how much? What is the formula I can write, beta? F is equals to neta into A into your dV dV divided by your dx. dV divided by your dx part equation. So dx is given for me what beta? Thickness. So if I simplify this one, force is how much for me? 10 power minus 3 Newton. Simplify it better. Force is given for me. Efficient is also given. Area is given for me 10 to the power of 3 centimeters square. A tangential force of 10 power minus 2 beta. This is not minus 3. This is given as 10 power minus 2. So force is 10 power minus 2. Correct the question. So this one is 10 power minus 2. So tangential force is 10 power minus 2. That is equals to neta. We need to calculate. Area is 10 to the power of 3 into 10 to the power of minus 2 whole square. That means it will become for me 10 to the power of minus 4 into velocity. Velocity is given as 6 centimeters. So it will be 6 into 10 to the power of minus 2 divided by 6 mm 10 to the power of minus 3. Simplify for this one, we'll get the value of neta. Nandini, why option A beta in the first question? Is it for the first question or second question answer? Option A. So how much I'm getting this one? We can do the calculation. 10 power minus 2 is equals to neta into 10 power. This one is minus plus 3 minus 4. So this will be equal to how much beta? 10 power 3 divided by 10 power 4. So this will get cancelled into 6 into 10 to the power of minus 2 into 10 to the power of your plus 3. Isn't it? So this will become how much for me beta? Minus 3. This is 10 to the power of minus 2. That means I can write it as if 10 to the power of your 2. Isn't it? So that means it will become for me 10 to the power of 1. So if I'm representing the coefficient of viscosity, neta is equals to 0.01. The unit of this one will be equal to your Poiseuille. But the options are given in poise. One Poiseuille is 10 Poiseuille. So this will be equal to 10 poise. Okay. So option A will be the answer. Second one, sir. Okay, very good. So this is the formula you need to remember. F is equals to your neta into your A. F is equals to neta into your A into your dV divided by dx. Clear for everyone? Sure. With an increase in temperature, the surface tension of the liquid, except molten copper and cadmium, what happens? Increases, remains same, decreases, first decreases, then increases. You should give me the answer, Rita. Anyone? With increase in temperature, surface tension of the liquid. See, generally it is advised to wash your clothes with hot water. Isn't it? Reason for that one, dust tondarga easy it will be removed rather than using the cold water or rather than using the surface, what do you call that one? Detergents. Option C, very good. So with an increase in temperature, because surface tension is nothing but what are formulas bit of a surface tension? Force per unit length is one formula. Another formula is surface tension is also equal to work done per your unit area. When you are increasing the temperature means you are decreasing the surface area. Sorry, you are increasing the surface area. When you are increasing the surface area, what is happening to surface tension? Surface tension of that liquid decreases. So I can write here with increase in temperature, surface area increases. Surface area increases. If surface area is increasing, inversely proportional. So if area is increasing right now, so what is happening to surface tension? Surface tension decreases. So it will be your decrease. Okay. So with increase in temperature, the surface tension of a liquid, except your molten copper and cadmium, it will be decreasing. Sure. Next question. Determine the energy stored in the surface of your soap bubble of radius 2.1 centimeter if surface tension is 4.5 into 10 to the power of minus 2. Can anyone do better? Determine this energy stored is equals to how much? If the in the surface of a soap bubble of radius is given, r is equals to 2.1 centimeters. If tension is given for me, surface tension is given as 4.5 into 10 to the power of minus 2. Unit is Newton per meter. Shall I try to do it better? Anyone? Option C. What is the formula, beta? I just now told you, surface tension T is equals to work done divided by area. Is asking the energy stored. Energy stored means surface energy, you know. So this is nothing but equal to your surface energy divided by surface area. Divided by surface area. That means surface energy will be equal to how much? Surface energy is equals to surface tension into your area. As it is soap bubble, it has two surfaces. So I can write here, work done or energy is equals to surface tension into area of this one is 4 pi into r square into 8. Sorry, by 8 into 2. Into 2. So energy U is equals to, what is surface tension given for me, beta? 4.5. Okay. 4.5 into 10 power minus 2 into 4 into 3.14 into radius is given as 2.1 centimeter. 2.1 into 10 to the power of minus 2 whole square into your 2. So 2.1 I can take it as 2 approximately, beta. You can simplify it and see how much I'm getting the answer. How many of you can give me the answer for this one? (4.5) into 10 to the power of minus 2 into 4 into 3.14 into 2. Calculate it. Option C. Very good. 4.98. Yeah. करो बेटा आप लोग कैलकुलेशन करो एक बार. It's very important here. Then what is the answer? 4.98 into 10 to the power of minus 4 joules. Third option. Very good. This you try to do it better. A mercury drop of radius 1 centimeter is sprayed into 10 to the power of 6 droplets of equal sizes. The energy expended in this process is surface tension of the mercury is equals to 32 into 10 to the power of minus 2. Mercury drop radius is given as of your 1.0 centimeters sprayed into number of droplets is 10 to the power of 6 droplets. Okay. Of equal size. The energy expelled U is equals to how much? If surface tension is equals to 32 into 10 to the power of minus 2 Newton per meter. So try to do it out better. Mercury drop of radius 1 centimeter is spread into. So this is your mercury drop beta. A larger drop of radius capital R is broken down into your n number of small droplets, like 1, 2, 3, so on like that. Yesterday I told you the relation between them beta. Capital R is equals to n to the power of 1 by 3 into your small r. Okay. So radius of the bigger droplet is equals to your n times of your mercury drop. So that means this is a radius of bigger droplet. That means it should be capital R. So it should be 1 centimeter, 1 into 10 to the power of minus 2. That is equals to n to the power of 1 by 3 into your small r. So that is 10 to the power of minus 2 right here, right now. 10 power minus 2 is equals to 10 power 6 into your small r. So small r is equals to, this will become for me 10 power minus 2 divided by 10 power 6. That will be equal to 10 power minus 2. So that will become how much for me beta? 10 to the power of your minus 6 divided by this one. This one is how much for me? Capital R, n to the power of 1 by 3, this one. To the power of your 1 by 3. To the power of 1 by 3. So that will come out for me. How much beta? 10 power minus 2, 10 power 6. So that will come out for me 10 power minus 4 meters. Okay. So now work done or energy is equals to surface tension into your final area minus initial area. Very good. So surface tension is given for me. So that is equals to T into N into 4 pi into your small r square minus 4 pi into your capital R square. That is equals to T into 4 pi will be common into N times of your small r square minus of your capital R square. So that will be equal to your 4 pi into your capital T into N number of droplets 10 to the power of 6 into this one is 10 to the power of minus 4 whole square minus capital R square. Capital R square is how much for me? 1 centimeter. That means 10 to the power of your minus 2. Okay. So that will be equal to your 4 pi into your capital T into this is 10 to the power of 6 into 10 to the power of your this one is 4 until 1, 2, 3, 4 whole square minus 1 by 100. Okay. So 6 will be going right now here. So this will be simplified 4 pi into your capital T into this will become for me LCM. You can do it out better. You just see the calculation that gave me the energy. Surface tension is also given for me. Pi value is 3.14. Can simplify this value better. This value will be coming out for me 4 pi 0.99 divided by 100. So this is 0.99 divided by 100 approximately. So it is 4 into 3.14 into surface tension is given how much beta in the problem? 32 into 10 to the power of your minus 2. Okay, into 0.99 means I can take approximately and try to simplify it. We'll get the answer for this. C is the answer. Okay, very good. 3.98 into 10 to the power of minus 2 joules. Okay, sure. Next one. When a glass capillary tube of radius 0.015 centimeter is dipped in water, the water rises to a height of 15 centimeter within it, assuming the contact angle between water and glass tube is 0 degree. The surface tension of the water is how much? Density of water is 1000 kg per meter cube and G value is 9.8. Come on, do it better. When a glass capillary tube of radius 0.015 centimeter is dipped in water, the water rises to a height. So tube radius is given for me. R is equals to 0.015 centimeters. And height to which it is been rising is also given as 15 centimeter. Assuming the angle of contact, that means theta is equals to 0 degrees. Surface tension of water is how much? Density of the water is 10 to the power of 3 kg per meter cube. And G value is given as 9.8 meter per second square. Come on, try to do it better. Can anyone give me the answer? What is the formula, beta? Nandini, what is the formula for surface tension, beta? H is equals to 2t into your cos theta by your r into rho into g. Is asking us to calculate what is the problem? Surface tension of the water. That means T. So T will be equal to how much? Surface tension T is equals to your H into R into rho into G divided by 2 into your cos theta. Height is given as 2 centimeter. That is 2 into 10 to the power of minus 2. The radius is given as 0.015 centimeter. 0.015 centimeter. 10 to the power of minus 2. Option A you are getting a yeah. Into density of water is given as 10 to the power of 3. G value is nothing but 9.8 divided by this one is 2 into cos theta value is 1. So it is 2 divided by 100 into 0.015 divided by 100 into 1000 into 9.8. This two zeros, this one and this one will get cancelled. So it is 2 into 0.015 into 9.8. This 0 is gone and this 0 is also gone, divided by your 10. Okay, so that will give me the answer. It is 0.11 Newton per meter. 0.11 Newton per meter, A option. Very good. Next one. A liquid does not wet the sides of the solid if angle of contact is obtuse 90 degrees, acute and 0 degrees. Can anyone tell me what is the answer, beta? The liquid does not wet the sides of the wall if the angle of contact is anyone? Option A, obtuse, very good. If it is greater than 90 degrees, obtuse. Okay, very good. Theory question directly. Next one. Two drops of equal radius coalesce to form a bigger drop. What is the ratio of the surface energy of the bigger drop to the smaller drop? Come on, try to do it. Two drops of equal radiuses coalesce to form a bigger drop. Bigger drop. This one and this one are coalescing to form a bigger drop. What is the ratio of the surface energy of the bigger drop to smaller drop? Okay, this one is capital R and this one is nothing but smaller. The energy is small ui and this is your u final. Or else you can write this one as u smaller and this one as of your energy of bigger. Come on, try to do it better. Energy is equal to how much, beta? Initial energy will be equal to your surface tension into your area. It is 4 pi into your small r square. And this will be your u final, beta. U final will be equal to your surface tension T into 4 pi into your capital R square. Okay. So two drops of equal radius coalesces to form a bigger drop. What is the ratio of the surface energy of the bigger drop to the smaller drop? So two drops. So what is the relation between small r and capital R, beta? Capital R is equals to n to the power of 1 by 3 into your small r. Isn't it? Capital R is equals to n to the power of 1 by 3 into small r. So how many droplets are there, beta? Two droplets. Yani capital R is equals to your 2 to the power of 1 by 3 into small r. Clear? That is the radius of the relation. So we need the ratio of your what is the ratio of surface energy of the bigger drop to smaller drop? That means u final divided by u initial. U final divided by u initial. Surface tension, you will get any of cancel. U final is 4 pi into your capital R square divided by 4 pi into your small r square. 4 pi and 4 pi is getting cancelled. So from this one I can write capital R by your small r. This is capital R divided by small r whole square. Capital R by small r is equal to how much beta? From this one I can write capital R divided by small r is equals to 2 to the power of 1 by 3. That means this one is 2 to the power of 1 by 3 whole square. That will be equal to how much? Options are given as 2 by 3. So I can write as of your option C. Clear, beta? Very good. Two drops of equal radius collises to form a bigger drop. What is the ratio of the surface energy of the bigger drop to the smaller drop is asking. So these two droplets are collising. So Ui means energy of the smaller droplet. Uf means energy of the bigger droplet. Initial energy formed by surface tension into 4 pi into r square beta. And bigger droplet energy is T into 4 pi into capital R square. And you know the relation between capital R and small r beta. Capital R is equals to your n to the power of 1 by 3 into small r. How many droplets there are? 2 droplets. So in the place of n is 2. 2 to the power of 1 by 3 into small r. So U final by U initial. This value divided by this one. T and T anyhow will get cancelled. 4 pi into capital R square divided by 4 pi into small r. 4 pi will get cancelled. So it is your capital R divided by small r whole square. That is 2 to the power of 1 by 3 whole square. So that means this will become for me 2 to the power of 2 by 3 is to 1. So third option will be the answer. Clear? Eh? Is it clear for everyone? Chalo, next question. The excess pressure inside a spherical drop of water is 4 times the another drop. Then the respective mass ratio is how much? Chalo jaldi se karke batao beta. The excess pressure inside the spherical drop. Excess pressure inside the spherical drop formula. Delta P is equals to 2T divided by R. For the soap bubble, if I am taking, for the soap bubble, delta P will be equal to, it has two surfaces, 4T divided by R. So the excess pressure inside a spherical drop of water is 4 times that of the another drop. Then their respective mass ratio is how much? Delta P is equals to 2T divided by R. So try to do it out bit. It is inversely proportional to what? Radius. So I can write here, excess pressure of the spherical droplet. That means delta P will be inversely proportional to your R, isn't it? And then the respective mass ratio will be equal to your how much? That is very important. I already told you so many times the relation between your mass beta. So mass of this one is right now, volume is directly proportional to your R cube because mass is equals to your volume into density. Volume is 4 by 3 pi R cube. Volume is equals to 4 by 3 pi into your R cube. So 4 by 3 pi is a constant. So volume is directly proportional to R cube, isn't it? Then he's asking the ratio of the masses. That means V1 divided by V2 is equals to your R1 divided by R2 whole cube. So delta P and delta R here inversely proportional. Pressure is given for me how much? Excess pressure inside the spherical drop of water is 4 times that of the another droplet. That means this is your excess pressure of the first droplet divided by excess pressure of the second droplet is equals to your R2 divided by your R1. Here I can take it as small r also, no problem, anything is fine. So delta P is equals to your delta P1 divided by excess pressure. The excess pressure inside the spherical drop of water is 4 times that of the another droplet. That means for this value, if I am taking right now, this one is 4 times of your delta times of P1. That is equals to your R2 divided by R1. That means I am writing right now 1 by 4 is equals to R2 divided by R1. Okay. P1 by P2 is equals to 1 by 4. So V1 by V2 is how much? Now I hope you can get the answer for that one. Mass already we got. Mass is equals to volume into your density. Anyhow for the liquid drop, density will be the same. So M1 by M2 is equals to V1 by V2. Yes. R2 by R1 means this one will become how much for me beta? R2 by R1 is equals to your 1 by 4. V1 by V2 will be equal to how much beta? So दिखा लो इसको. V1 divided by V2 will be equal to your. Okay. So I'm writing here ulta of that one. That will become for me 4 to the power of your cube. Isn't it? So that means mass ratio if I'm writing here, M1 by your M2 will be equal to V1 by V2. So V1 by V2 is equal to how much for me? 4 cube. 4 4 is 16. Isn't it? 16 is 2. That means M1 by M2 is equal to how much for me? V1 by your V2. I have written correctly only, no? Delta P1 by delta P2 is R2 by your R1. Correct only I have written. V1 by V2 will be equal to your R1 by your R2. The excess pressure inside the spherical droplet is 4 times that of the, okay, delta P1 is 4 times beta. It's not P2, sorry. So this will become for me same relation only thing is I need to change the values. So delta P1 divided by delta P2, that is equals to 4 times of your delta P2 divided by delta P2. This one is getting cancelled. So this one will be equal to how much for me beta? 4. And this one is right now for me your R2 divided by R1. So R2 by R1 is equals to 4. That means I can write here V1 by your V2 is equals to R1 by R2 means 1 by 4 I'll be getting. So this one is 1 by 4 cube. So V1 by V2 means this will become for me 1 by 64. So D option will be the answer. 4 into 4 into 4. Okay? Sure. Option D. Very good. Next question. Very important medal beta. A balloon with a mass m is descending down with an acceleration a, where a is lesser than g. How much mass should be removed from it so that it starts moving up with an acceleration a? Good question beta. See here, this is your balloon. Say for example, some balloon I'm having. Okay, a balloon of mass m is descending down. Like say this is some balloon. Okay, is descending down with an acceleration. Okay, this is moving down with an acceleration a, and this a value is lesser than g is telling. How much mass should be removed from it so that it will start? This I'll take it as capital M because original mass I'm taking right now. So I'll remove this one. This one is capital M. So originally the mass of the, okay, he has given small m only, small m. Again, I'll be removing capital M. Okay, it will be important. The mass, a balloon of mass m is descending down with an acceleration a, where a is lesser than g. How much mass should be removed from it? Okay, you make this one otherwise capital M. That will be more better. So that will be giving me the answer perfectly. Okay, anyhow, anything is fine otherwise. If you're not comfortable with that one, you can also make small m and try to do it, no problem. See, this is your balloon, some balloon of mass m moving down with an acceleration a. Tell me what are the forces acting on this one body? The weight of the body is right now acting in the mg. And normal force will be acting in the upward direction. That means tension. Some tension force is acting in the downward direction. As it is moving in the downward direction, mg minus the opposing force because of the buoyant air will be equal to your m into your a. Okay. Now from this balloon, I'm removing certain mass. Like say m dash is been removed from this one. So this one is your, so remaining mass will be m minus of your m dash. Okay. So what I'm doing is, if m dash is removed, if m dash is removed, so weight of this body will be equal to how much beta? M minus of your m dash into your g. Normal of this one is anyhow will be acting in the upward direction. That is nothing but equal to your m in the upward direction. So now as the body is, when you're removing it, so that it starts moving up. Now it's moving up with an acceleration of your a. For this equation, how do you write beta? N minus of m minus of your m dash into your g is equals to m minus m dash into your acceleration of your a. Okay, so this one is your equation number 1 and this one is your equation number 2. So solve these two equations better, see what I'll be getting the answer. A balloon of mass m has been descending down with an acceleration a, where a is lesser than g. How much mass should be removed from it so that it starts moving up with an acceleration of your a? This is a balloon of mass m beta. So before removing anything, it is moving in the downward direction, and buoyant force is acting in the upward because of the air. N is not normal only beta. It is only the normal force due to the air molecules, because normal will come only when it is in contact with any surface. Here this normal, I am assuming it as of your force exerted by the air in the upward direction. So mg minus n is equals to your m into your a. So if m dash is been removed, the remaining mass will be m minus m dash. So now the body is moving in the upward direction. Weight of the body is m minus m dash into g in the downward direction, n in the upward direction. So equation will be upward force minus downward force is equals to mass into your acceleration. Clear, beta?
Yes, sir.
Now, can you solve the equation 1 and 2, beta? Solve the equation 1 and 2 and see what I'll be getting the answer for that. So add these two equations, beta. That's it. Adding 1 and 2. First equation is what for me? Mg minus of n is equals to m into your a. Another equation is how much for me? N minus, this one is m minus of your m dash into your g is equals to your m minus of your m dash into your a. Add both of them, beta. What I'm getting? This one and this one will get cancelled. So this will be equal to your mg minus of your m dash into your g. So this one is, if I'm adding both of them, so it is your mg. This one is gone right off. It is minus of your m minus of your mg. So this will become for me your m dash into your g plus of your a will be equal to your 2 times of your m into your a. That's it. That means it's asking m dash. M dash will be equal to your 2m into your a divided by g plus of your a. That will give me the answer. I'm just taking all the m dash on one side, but that's it. This is because if I'm simplifying this one right now, option 2m into your a divided by a, isn't it? So this one you see, this is your m into your g minus of your m dash into your g is equals to your m into your a minus of your m dash into your g. This minus and this minus, isn't it? That will become for me 2 times. That is g plus a. This one is your acceleration a, not a. This one is your acceleration a. So if I'm taking right now, that will become for me 2 times. Acceleration will become for me 2 into your mg. This one is your mg. This mg will get cancelled. So simplified. So it is m dash into g plus a is equals to 2m into your a. Okay. So m dash is equals to 2m into your a divided by g plus a. Which option is matching with that one? 2m into your a divided by g plus a. So first option will be the answer. So next question. A certain number of spherical drops of liquid of radius small r coalesces to form a single drop of radius capital R and volume V. If capital T is the surface tension of the liquid, then what is the energy? Is it released? Is it absorbed? For the first you tell me that relation better. Certain drops of spherical droplets of coalesces to form a single droplet. So when this one is being coalescing to form a bigger drop of radius capital R. So always energy is released. Energy is released, not observed. That means second option is not possible, fourth option is not possible. The answer should be either in the A and as well as of your B. Whenever the smaller droplets are being combining to form a bigger droplet, energy is being released. Reverse of that one, energy is observed. You try to remember that one better. I hope you can do this one better. I told you in yesterday's session of your class also. Should I need to do it? Will you try it? Option A. Option A vastunda. Let me check it out once. A certain number of droplets. Okay. N number of droplets, n into 4 by 3 pi into your small r cube is equals to larger bigger droplet 4 by 3 pi into capital R cube. This is the volume of the body. That means I can write here n into 4 pi into small r cube is equals to 4 pi into your capital R cube is equals to 3 times of V I can take, isn't it? So when energy is being released, so energy will be equal to surface tension into change in area. So that is your T into your n times of your 4 pi into your r square into your n minus 4 pi into your capital R square. See here, n into 4 pi into your r cube is equals to 3v. That means 4 pi into your r cube can be written as of your 3v divided by your n. How many droplets is telling beta? N number of your droplets only, no? So n number of your droplets means I can write as that one relation. Understand? So that is equals to T into your 4 pi into your R cube. I can write this one as 4 pi into R cube means from here I can write 4 pi into your R square is equals to 3V by N into small r. The same way 4 pi into capital R square will be equal to 3V by capital R. So it is 4 pi into R square is 3V divided by N into your small r into your N minus 4 pi into R square is 3V divided by capital R. This and will get cancelled. So that is equals to 3V will be out into T into 1 by your small r minus 1 by your capital R. So this will be the energy. 3V into T divided by 3V into T into 1 by small r minus 1 by capital R. Which option? Third option will be the answer. Nandini. Clear, beta? Sure.
Sir,
हाँ बेटा.
next slide.
हाँ.
Done, sir.
Sure. Next question. A wind with a speed of 40 meter per second blows parallel to the roof of your house. Okay. So this is your roof of your house. Okay. So it is flowing parallel to this one. The wind with a speed 40 meter per second blows parallel to the roof of your house. The area of the roof is given as 250 meters square. Assuming that the pressure inside the house is atmospheric pressure. Okay, pressure inside is zero right now. Atmospheric pressure and pressure P2 is equal to your P here right now. And here the velocity will be V2 and here will be the velocity V1. V2 will be equal to 40 meter per second because it is moving parallel to this one, this pressure. And this air is moving in the upward direction. And here V1 will become 0 because there is no motion of the the hut or maybe this roof of the house. That will be equal to your 0. So V1 will be equal to 0. Wind is blowing with velocity V2, isn't it? So this is right now P2 and this one is your atmospheric pressure. You know that force formula, dynamic lift formula. What is asking? Assuming that the pressure inside the house is atmospheric pressure, the force exerted by the wind on the roof and the direction of the force will be equal to how much? So obviously the direction of the force will be in the upward direction, isn't it? And how do you calculate the force formula? Beta? I told you dynamic lift formula. F is equals to your half into rho into your V2 square minus of V1 square into your area of cross section. So that is equals to your half into your density of the air. There is not pressure. This is your density of your air. Density of your air is 1.2 into 10 to the power. Okay, 1.2 only. Kg per meter cube. So it is half into 1.2 into velocity V2 is your 40 square, V1 is equals to 0 into area. Area of cross section is 250. Simplify it, we'll get the answer for this one. Why V1 is 0 beta? Because roof is not moving. That is the reason the velocity at lower portion will be 0.